Hello everyone, welcome to today's class. This is Teacher Simon taking you through Pure Mathematics, paper 9701/31 for May, June 2025. Question number 1 is coming from modulus functions. Part A, they are saying sketch the graph of y is equal to x plus 3. So the first thing we are supposed to do is to draw a graph of y is equal to 2x minus 3. I can create a small table here, and then I look for the intercepts. If x is 0, y will be negative 3. If y is 0, then take the negative 3 here, it becomes a positive, so 3 over 2. That one will give us a 1.5. Okay. Now I'll put my axes, then label them. This is x, this is y. We have 0, negative 3. So let's say this is maybe 1, negative 2, negative 3. Then we have 1, then 2, then 3. Then we have maybe 1, 2, 3, like that. Now 0, negative 3 is here, and then 1.50 is here. So I can draw this one here, and of course this one continues. Okay, but we are not supposed to consider this negative part. Okay, we reflect the x, that part of this graph that goes beyond the x-axis, we reflect it in x-axis. Because this is modulus, we're supposed to continue to consider the absolute value of y. Okay, so meaning I will have this one here reflected in there. So remember this one, this graph here was passing through the negative 3. So when I reflect it in here, it will pass through the 3. Okay, so that's what we are supposed to have. This part here, you can rub it off, or you can leave it what? Dotted, like this. You see? So this is actually the positive part. It was already positive. Now you know that when you reflect something, when you reflect the graph in x-axis, y becomes a negative. Like y changes the sign. What was negative now becomes the positive. You see that? Okay, so that means this one is y, which is equal to negative of 2x minus what? 3. So that is that. Then part B, solve the inequality 3x minus 1, then less than the modulus of 2x minus 3. Now, from here, we can see, we can also sketch this one here on the same graph. Okay, so suppose I have y, which is equal to 3x minus 1, and then I try to sketch this. Let me get just 2 coordinates here. I have x, and then I have y. So if x is 0, this one will be a negative 1. Suppose y is 0, then that means x is going to be a third. So when I come to this one and I put 0, negative 1, this one will be here. Okay, and then we have a third 0. A third is 0.3 recurring. That means it can maybe be here. So meaning we can have this line here going through like that. You see? And this one, we are going to consider this part that goes beyond the what? Below the x-axis. For it, we consider it. Why are we considering it? Is because they didn't tell us modulus, so it was just that line there. Okay, it doesn't have the modular signs. But if the modular signs were there, then we would reflect it also in this y-axis, in x-axis. So this is the line y, which is equal to 3x minus 1. On the look of things, this y is equal to 3x minus 1 is only intersecting this negative part of this graph, the one that was reflected. It doesn't meet this one here. So that means when I'm writing here, okay, I'm going to have my 3x minus 1, then I say less than, it is intersecting the negative of this one. Remember, in modulus functions, we have the negative part and then the positive part. So suppose this graph here was intersecting the positive part, then I would consider this one intersecting this and then also intersecting this one, okay? And then from here, we can solve right away. So this is 3x minus 1, then less than, open the brackets here, we can have minus 2x, then plus 3. So when I bring this one here, it will add to the 3 of x, so we shall get 5x, then less than. If you take 1 here, that one will be a 4. So meaning x is going to be less than 4 over 5. As simple as that. And actually, even here, you can see that where these two are meeting, that is the 0.8, okay? That is the 4 over 5. Now, this line here, this inequality here, means that this line here must be below this one, okay? So if we have the 4 over 5 here, where this line is below this one here, that is when we are looking at the left of this point. So at the left, you will see that this one continues this way, it is below, and this one is going up. But beyond the 4 over 5, when you come to this other side, this line now is above this one here. You see that? So if you write x greater than 4 over 5, then that would be wrong. You see that? Okay. So that is that. Question 2 is coming from logarithms. They are saying it is given that 2 natural log of p, then plus natural log of p minus 1 minus a half natural log of q plus 1 is equal to 3. Find q in terms of p. Here we are going to use the rules of logarithms. So I will first put this one here, and then we have natural log of p squared, then plus natural log of p minus 1, okay? Then I will also put this one here. And what are we getting here? We are having minus, then the natural log of q plus 1, then to the power of a half, which is equal to 3. Now, this is addition of logarithms, then we shall multiply the powers. So we have natural log of p squared, then times the p minus 1. And then this is subtraction. I will divide. So divide by the q plus 1, then to the power of a half. This one will be equal to 3. Okay, then from there we have a rule in logarithms that natural log or logarithm of a b is equal to c. That means a power c then is equal to b. Okay, so we shall have a power c then which is equal to b. Remember, natural log is the same as log of e. Okay, now of the whole of this here is equal to 3. So I will say e power 3 then is equal to this one here. Okay, so we shall therefore have what we have here, then we equate it to e power 3. E power 3, then we can cross multiply, and then we have p squared into p minus 1, then we shall divide it by e to the power of 3, which will be equal to q plus 1 squared, to the power of a half. Then we can square both sides. When we do so, we shall have p, it will be to the power of 4 now, then p minus 1 squared, then out of e to the power of 6, not so? Then which would be equal to q plus 1. Of course, now you can bring 1 this other side. This simply implies that your q is going to be equal to p to the power of 4 into p minus 1 squared out of e to the power of 6, then minus 1. Or you could actually leave it. You could maybe just write this one squared, you get it, then minus 1. But me, I simplified it, no problem. Question 3 is coming from complex numbers. Find the complex numbers z for which z plus 5i out of z minus 5 is real, and the modulus of z is 17. Give your answers in the form z is equal to x plus iy, where x and y are real. Now, I'll let my z to be this x plus iy, okay? So this simply implies that the z plus 5i out of the z minus 5 then will be x plus iy plus 5i, then we shall divide by x plus iy minus the 5, okay? Then after here, I can actually write this as, I can separate the real from the imaginary. So we have x then plus y plus 5i. Then here we have x minus 5 plus iy, okay? And then I'm going to rationalize the denominator. So we multiply the conjugate, of the denominator through, or we can say multiply the numerator and denominator by the conjugate, okay, by the conjugate of the denominator. As simple as that. That is what we call rationalizing the denominator. Okay, so this simply implies that we shall have x plus y plus 5 of I, then we multiply by this x minus 5, then minus iy. The same thing we do here, down x minus 5, then plus iy, we multiply it by the x minus 5, then minus iy. Remember the conjugate of the denominator, we just change the sign of the imaginary part. You see that? So here it is a plus, then it's a minus. So what I do down here is what I do up here. So it's like I've done nothing because this one can easily cancel with that one. You see? Now we open the brackets. So to open the brackets, x has to multiply everything here. We shall get x squared minus 5x, then minus xy I. Then we come to this one times here. I will have y plus 5. Let me do it once and for all. So y here times x, we shall have xy, right? So we shall have xy, but there is an I here, okay? Then y times this negative 5, that will be minus 5y with an I, remember. Then 5i here times x, that one will give us 5xi. Then 5i times negative 5, isn't that a 25? So negative 25i. And then what else? Now we multiply this one in here. So we have yi then times negative iy. So this one will be minus y squared I squared. But remember, I squared is equal to negative 1. So that means this one will be a plus. Okay? So we have plus y squared. Okay? Then 5i. Okay? 5i then times this one here minus iy. So we shall get negative 5y squared. And also, no, it is the I which is squared. Minus 5y, then I squared. Then this one becomes a positive 5i. So positive 5y, not I. Positive 5y. So that is what I'm going to write here. Then over, I'm not going to waste time here. This is a difference of two squares, okay? You have a plus b, then into a minus b. That is your a squared minus b squared, not so? So this is our a, this is our b. You see that? A, then b. The minus is, and the change in the sign is only there. So I'm just going to put this x minus 5 squared, then minus. Here we are going to have iy squared. Okay, let us simplify this one here. We put the real parts together. We have x squared, there is plus y squared, then there is minus 5x here, then of course this one will go with that. Okay, what else do we have? There is 5y here, so plus 5y. Then I'll divide this one by what we are having down here, which is x minus 5 squared, then plus y squared, because here we are going to have minus y squared. Remember, I squared is a negative 1, so minus and a minus, then it becomes a plus here. Okay, then after that, this is the real part. So the imaginary part, we look for those entries that have gotten what? I. So there is 5x, which is here, then minus 5y, then there is minus 25. You see that? And this one is going to be over x minus 5 squared, then plus y squared. And this one here is I. Okay? All right. Now, what else are we having? They said the modulus of z is equal to 17. Not so? And they also said that this thing here is real. So if it is real, that means there is no imaginary part. This imaginary part is 0. Okay? So I will say if z plus 5i over z minus 5 is real, then 5x, or I can say, let me just write it all together, the imaginary part, then the imaginary part is equal to 0. So we have 5x minus 5y minus 25 out of x minus 5 squared plus y squared is equal to 0. So meaning if we cross multiply, this one will go, and then we have 5x minus 5y minus 25, which is equal to what? 0. I can write x in terms of y or y in terms of x. So x here will be equal to, when I take these ones this side, in fact we can say 5x is going to be 5y then plus the 25. So meaning x is going to be equal to y plus 5. Like when you divide it by what? By 5. Okay, I'll keep that. Then they also said that the modulus of z is equal to 17. So meaning root of x squared plus y squared shall be equal to 17. When we square both sides, that means we shall have x squared plus y squared, which is equal to 17 what? Squared. Remember, x is this one here. So meaning I can have y plus 5 squared then plus y squared is equal to 17 squared. So expanding here, we are going to have y squared plus 10y then plus 25 plus y squared. Okay, then I can bring this one here. And by the way, let me first check again. It was given as root of 17, sorry. It was given as root of 17. That means when we square both sides, then that square root will go. So I'll put off this square here. Then minus the 17, this one will be equal to 0. Now from here, we have 2y squared, then plus 10y, 25 minus 17. This one gives us 8 also. So it gives us 8, which is equal to 0. Divide all through by 2, that will be y squared, then plus 5y, then plus 4, which is equal to 0. Factorizing this will be y plus 1, and then y plus 4. Because when you multiply these two, they give you the 4, and when you add them, they give you the 5. Okay, so meaning y is either equal to -1 or y is equal to what? -4. And then what would be x when y is -1? So we shall have -1 plus 5, which is actually 4. And then here we shall have -4, then plus 5, then this one will give us a 1. So meaning z1 can be x, which is 4, and then y is a -1. So I'll write -1i, but that one we don't write it. So I'll just write 4 minus what? I. And then from there, z2 is going to be equal to x is 1. So we shall have, 1, then minus 4i. Remember, z is x plus iy. So where there is x and y, you put their values. As simple as that. Question 3 is coming from parametric differentiation. The parametric equations of a curve are x is equal to e to the power of tan t, y is equal to 3 tan squared t. Find the equation of the tangent to the curve at the point E3. Okay, give your answer in the form y is equal to mx plus c, where m and c are exact. Okay, now we need to find dx dt. So if x is equal to e to the power of tan t, remember when we differentiate, okay, a function that is e to the power of f of x, this one is equal to e. No, it is equal to, you get the power here, you differentiate it, so you have f prime of x, then you multiply all through by e to the power of f of x. Okay, so this is what we are going to apply here. That means our dx dt is going to be equal to, when you differentiate tan t, you get sec squared t. You can even check in the list of formulae to differentiate tan x, you get sec squared x. You get it? Then after, we shall multiply with e to the power of tan of t. You see that? Then after that, let's go to y. So y is equal to 3, then tan t, let me say, this one squared here. The square that is here, I'm going to write it like this. It is the same. Then dy dt shall be equal to, drop this power, so it will become a 6. So 3 times that, 2 there. Then tan t, you reduce the power by 1, okay? Then from there, you enter inside here and differentiate this. That one is going to be sec squared t. We do this by using chain what? Rule, okay? Now from there, this simply implies that we shall have 6 tan of t, then sec squared t. For us to get dy dx, this one will be equal to dy dt times dt dx, okay, times dt dx. And then dy dt, we have gotten it as 6 tan t, then sec squared t, then times dt dx is 1 over dx dt, okay? So we shall put 1 over, this is sec squared t, then e to the power of tan t, okay? So sec squared t will disappear, and then our dy dt is going to be equal to 6 tan t divided by e tan t as its power. You see that? Now, this expression for dy dx is the one that is, it is actually called the gradient function, okay? So they give us a point. Remember, to find the equation of a straight line, we need to get the gradient and at least one point through which a line passes. So they gave us a point. The point was given as E3. The x coordinate is an E, okay? Now, at E, then 3, this simply implies that we have E power 1, then we have E power tan t, okay? This is the x coordinate. You get it? This is x, this is y. So I get the E, I equate it to the expression for the x. Now, since the bases are the same, that means the powers are also equal. So we shall have tan t, which is actually equal to 1. So meaning t shall be equal to the arctan of 1, which is pi over 4. Okay, so I need to get the values of t, because the value of t, because it is the one that I'm going to substitute in here. You see that? Okay, so this therefore implies that our dy dx is going to be 6 tan t. I can even just take this one. Tan t is 1. So times 1, then out of e to the power of 1. So therefore, you have 6 over e. You see that? Then what else do we have? We have now, that is our gradient. So using y minus y1, which is equal to m into x minus x1. So we have y minus, our y1 is 3 here, so minus 3, then is equal to our m is 6 over e, then into x minus our x1 is what? The e there. So now when we multiply through, we shall get a 3 here, then 6 over e of x, then minus the 6 here. You see? And then we can take this 3 here, it will become a positive. So minus 6 plus 3, of course that one will give us what? A minus 3. So minus 3. This becomes our answer. They said M and C are exact. So our m is this 6 over e, and then the c is that minus 3. Question 5, the polynomial 3x cubed then plus pax squared plus 7a squared of x then plus qa cubed is denoted by f of x, where p and q and a are constants and that a is not equal to 0. Okay, when f of x is divided by x plus 2a, the remainder is negative 22a cubed. When f of x is divided by 3x minus a, the remainder is negative a cubed. Find the values of p and q. So now using the factor remainder theorem, okay, f, when you equate this one to 0, x is going to be equal to negative 2a, okay? X will be equal to negative 2a. Now we shall put f of negative 2a, we equate to the remainder, which is negative 22a cubed. So let us substitute wherever there is x, we put this negative 2a. So here we have a cube, and then here we have a square, then 7a squared, then times negative 2a, and then plus q, then a cubed. This one is equal to negative 22a cubed. And then when we try to simplify, this order power of a negative is always a negative, so negative 2 power 3, then that will be negative 8 times 3, that will be negative 24, then a cubed. This one will be a 4, a positive. Even power of a negative is always a positive, so we have 4 a cubed, then p, then we have minus 14 a cubed, then plus q a cubed is equal to negative 22 a cubed. Now a cubed is common, so if I divide it all through, it disappears. Divide all through by a cubed, it goes. Then I'll have here, I'll remain with negative 24 minus 14. What will that give us? Oh, I can put everything together here, and maybe let me just write this one, negative 24, then plus 4p, then minus 14, then plus q. This one is equal to negative what? 22. So meaning 4p plus q, this one will be equal to negative 22, then plus the 24, which becomes a 2, not so? Then plus 14, isn't that a 16? Yes. So one equation is 4p plus q, which is equal to what? 16. I can keep that one there. Okay. Then I also go to this other one here, that when f of x is divided by this, the remainder is this. So again, when we get this 3x minus a, we equate it to 0, then x here is going to be a over 3. So meaning that when now we get f of a over 3, then we should equate it to the remainder, which is negative a cubed. Now we substitute, so we shall have 3 into a over 3, but there is a cube, then plus pa, then we put a over 3 squared, then we have 7a squared into a over 3, then plus q a cubed, then this one is equal to negative a cubed. Okay, then from here, what else are we doing to simplify? So this one will be a cubed over 27, so times 3, that one will be 1 over 9 of a cubed. Okay, then plus this will be a cubed of p, then over 9, then we can also have 7a cubed over 3. Then we also have qa cubed, which is equal to what? Negative a cubed. Again, we shall divide all through by what? A cubed. Okay, so when we do so, then we are going to have 1 over 9 plus p over 9, then plus 7 over 3 plus q, then shall be equal to negative 1. Then I'll multiply all through by 9 to eliminate the denominators. That means here we'll have 1, then here p, and then the 3 goes into 9 3 times, so 3 times 7, that will be a 21 also. Then plus 9q, 9, then q, which is equal to negative 9. So, meaning we shall have p plus 9q, which will be equal to negative 9 here. And then we take this 21 and the 1 the other side. So we shall have minus 22. Not so? So that means our next equation is p plus 9q, which is equal to negative 31. You see that? Now this is my other equation. So I have two simultaneous equations which I can solve. Okay? So solving 1 and 2, we have 4p plus q, which is equal to 16, and then 4 plus 9q, which is equal to negative 31. I can eliminate p, multiply 1 here, then here 4. So we have 4p plus q is equal to 16, then 4p plus 9 times 4, that is a 36 q, and then 31 times 4, 30 times 4, that is 120. Not so. So it will be 124, negative 124. So I'll subtract here to let go of p. So when I do so, q, 1 here minus the 36, that will be a negative 35. Negative 35 of q, and then 16 minus minus. So here we are adding. And then 24 plus 16, don't you get 40? So this one will be positive 140, meaning q is equal to, first of all, 35 times 2, that is a 70. There are two 70s in 140. And then here we shall get a negative 4. Okay. So there are 4 35s in 140. Then how about p? We can substitute in any of them. So p, using the second one here, is going to be negative 31, then minus 9 of q. Okay, so negative 31, then plus 36. Isn't this a 5? So p is actually equal to 5. As simple as that. Question 6 is coming from complex numbers. It is given that z1 is equal to 3, then e to the power of 4 over, pi over 4i, z2 is equal to 3 over 2, e to the power of pi over 6i, and then omega is equal to 2, then e to the power of pi over 2 of I. Part A, state the values of omega z1 and omega z2. Give your answers in the form r, e, power I theta, where r is greater than 0, and theta ranges from negative pi to positive pi. So omega z1 is going to be equal to, omega is 2, then e to the power of pi over 2 I. Then we are multiplying by the z1, which is 3 here, then e power pi over 4 of I. So from here, 2 times 3, that is a 6. Then here e, we shall have to add these powers. Remember, these are indices. So if we are multiplying the same bases, we add the powers. Then plus pi over 4. This one will be that. So what do we come up with? This one here is I can multiply this one by 2 and also here by 2, such that I get a what? I get what we call the equivalent fraction. So a half plus a quarter, you get 3/4, not so. So that means we shall get 3 pi over 4 of I, as simple as that. Then omega z2, this one is going to be omega is this one here, then times z2 is 3 over 2, then e to the power of pi over 6 of I, same thing. So this times that, we shall get a 3, not so. Then e to the power of, again, pi over 2, then plus pi over 6, then of I. Now for this one, that means we shall get times 2, times 3, times 3. So we shall have 3 pi plus pi, that would be 4 pi over 6. So 4 pi over 6 is the same as saying by 2, 2. By 2, 3. So 2 pi over 3. Or we can say that 90 plus 30, because pi over 2 is 90. Then pi over 6 is 30. So 90 plus 30, that is 120. And that is twice 60, not so. And 60 is pi over 3. So this will be twice of 60. Then I. So this is going to be our answer there. See? Then part B, on a sketch on an Anagon diagram with origin O, show points A, B, C, and D representing complex numbers Z1, Z2, omega Z1, omega Z2, respectively. Okay, so I'm going to put my axis here. This is the imaginary axis. Now we have our origin here, 0. Now here we don't know the x coordinates and then the y coordinates, so we don't need to convert this one here, because e to the power of I theta is the same as cosine of theta, then plus I of what? Sine theta. So we don't need to do all of that. For even these 2 marks they have given us, it is just wastage of what? Time. So what we are going to do is to just estimate, like for example, first of all, these are 4 quadrants. Here, 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 and here. Now, Z1, I'll represent it with an A. So when you look at Z1, this is pi over 4. So pi over 4 can be like in the middle here, 45 degrees. You see that? 45 degrees. So if let's select this one to be there. 45 maybe there. And I'll let this one be point A. You see that? Then I go to point B for Z2. For Z2, this is 3 over 2. Now, this 3 over 2 is a half of this 3. That means, remember this one represents the length or the magnitude. So that means the length of Z2 has to be a half of the one of Z1. Are we there? Let me write here. Length of Z2 is half of length of Z1. You see that? So I'm going to draw this one. Let's say this is 30 degrees. 30 degrees is less than what? The 40. Not so. Like there. But it has to be a half. So I'll estimate, where do you think a half is? Maybe somewhere there. But then I put it to 30 degrees. It's an approximate. Okay. So this one is 1.5 units. This one is 3 units. Okay. This one is pi over 3. This one here is pi over 4. So this is point B. Then the next one is omega z1. When I look at omega z1, this is 6. Now this 6 is twice this one. You see that? But the angle, remember this one is 45. And these are 3 45s. So that is 100 and what? 35. Because 2 45s give us 90. So that means 135 is here. You get it? This is a 45. This is a 45. This is a 45. Do you see that? Okay. So I'm going to draw here. But this one has to be twice. Approximately twice this. Pardon me here. Approximately twice. So I'm looking for 100 and what? 35. So maybe there. And this point here is C. This one is 6 units. You get it? So remember, this one here is going to be pi over 4. Because already this one is 90. So 90, then plus the pi over 4. Then you'll get the other 3 pi over 4. You get it? A 135 lies in the second quadrant. Then how about this one? This is 120. And 120 is 4 times this. So this is 30, another 30, maybe that is 60, then 90. You get it? Then another 30, 120 has to be around there. Okay. So I will come to this one here again, and then I look for 120. But again, at WZ2, you can see that it is 3 here. So that means it is half. So let me also write this one here, that length of omega Z2 is half of length of omega Z1. You see that? Very important. So when I'm drawing this line also, I need to make sure that it is a half of this one here. And it has to be 100 and what? 20 degrees. So I pull off the 15 degrees from this line here. Okay, so 120. Just there. Is it a half? No. You can move it halfway. Halfway, probably around here. Then I'll go to 120 there. So this point here is D, which is 3 units. You see? And here, this one is supposed to be, remember it is 120, so this one is pi over 6. We are adding it on this 90. So that is going to be our Gann diagram. Then part C, state the geometric effects of multiplying Z1 and Z2 by omega. Geometric effects. Now, when you look at what we are having here, Z1 is given as 3e, then is it pi over 4? Pi over 4i, okay? Then omega Z1 is actually equal to 6, okay? then e to the power of 3 pi over what? 4 of I. Now, let's also look at z2, which is equal to 3 over 2 e to the power of pi over 6 of I. Then we have omega z2, which is equal to 3, then e to the power of 2 pi over 3 I. Okay. So which points here do we see? For z1 was represented by a, not so? z1. Then b, what did they do? B is z2. Let me just put these ones here. This is for z2. Then this is omega. For C, we are having omega z1. Then D, we are having omega z2. Now, I want you to see what is happening here. z1 to omega z1, we can see that the length, which is here 3 units, goes to 6 units. Are we there? That means this one is multiplied by a scale factor of 3. Eh? We say that is an enlargement of scale factor. No, it's not actually 3. This 3 times 2 is the one that gives us a 6, right? So it is enlargement by scale factor what? Scale factor 2. You see that? Are you recognizing that? Okay, so I will say we have enlargement by scale factor 2. Okay, maybe the center is the origin. If I can add that one on, center 0 0. You remember this kind of description in IGCSE? Enlargement by scale factor, then center 0 0, whichever center that you get. And then we are looking at, I'm seeing this and this is a times 2. Even here to here is a what? A times 2. Now let us look at the angles z1 and then omega z1. For z1, this angle here is 45. Remember? Then for omega z1, by the way, I think to put an angle here. No, it's already here. So this is 45. Now, if this is 45, this is another 45, then this is another 45. That means on this 45, we added the 90. Are we there? So we rotated this one here by 90 degrees. So we rotated it like this to come to this one by 90 degrees. I don't know whether you're understanding what I've done there. So in other words, when I come to this one here, to move from pi over 4 to 3 pi over 4, from here to here, let me even try to put this one a little bit down such that this one here is pi over 4, then plus pi over 2. So we are rotating with, it's a half turn. I mean a quarter turn, because 90 is a quarter of 360. So it's a quarter turn, but where are we going? Don't you see that it is an anti-clockwise movement? Yes. Okay, then how about this other one here? Let's also check it out. From 30 to 100 and what? 20. It has to be the same movement because it is describing both z1 and z2 multiplied by omega. Even this one is going to be pi over 6, then plus the what? The 90, 30 degrees, then plus 90 degrees, you get the 120. Does that make sense? Okay, so that means the next geometric effect that we can talk about is rotation through pi over 2. I can say maybe radians, okay, anti-clockwise. For rotation, you have to tell us, okay, I can also add on center. The center is still what? 0, 0. This one is optional, okay? So you have to tell us when you are rotating, are you rotating clockwise or anti-clockwise? You can easily see that this one was transformed into this. It is an anti-clockwise movement. This one here was transformed into this. It is also an anti-clockwise movement. You see that? Okay, so that is what we are having there. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.